Dear students, in the last lecture, lecture number 8, in case of design of flat slab, we have gone through the process of proportioning of the flat slab, that means thickness of slab, what will be the guidelines recommended by IS 456 to select the thickness of the flat slab, as well as other components like column drop and panel. So we have gone through what is the meaning of the panel, how we select the panel of a flat slab. Now in this lecture, that is lecture number 9, here we will be going through the process, that is methodology, direct design method, and this direct design method for calculation of various type of bending moment as well as shear force. We will be going through how we will be calculating the bending moment and redistribution of bending moment as per Indian Standard Code IS 456. So we will be covering this method of calculation of the bending moment in two parts, that means in two lectures, lecture number 9 and lecture number 10. So let us go through lecture number 9 today. Design methodology flat slab as per IS 456 recommendation, as we have already discussed some part of it. Now step number 2, determination of bending moment and shear force. So here IS 456 permits two methods. Number 1 is direct design method and the second one is the equivalent frame method. So first of all, let us try to understand what is the design method, that is first method, direct design method. What are the various guidelines which are given in codal provision, and for this we have to refer clause number 31.4 of IS 456. All the guidelines are very clearly mentioned in the code. We will be here try to understand it more clearly, that how the codal clauses or the guidelines recommended in the various clauses, how to apply. So first of all, in this method, that is direct design method, there are some limitations which are in the form of assumptions. So to apply this direct design method, we have to take some assumptions into consideration, which are mentioned in clause number 31.4.1. So for the application of the direct design method, it should fulfill some of the conditions which we are going to explain. Very first condition is this method is applicable when the flat slab consists of minimum 3 continuous span in each direction. So that means very first assumption is there shall be minimum of 3 continuous span in each direction. Second, the slab panel shall be rectangular and the ratio of longer span to shorter span within a panel. Now, no need to get confused that we are talking about the whole slab, but we are talking about here in second assumption panel of the slab. That means slab will be divided into various panels. Earlier lecture, in lecture number 8, we have gone through what is the meaning of panel, how will we decide what is panel. So second assumption is the slab panel shall be rectangular and the ratio of the longer span to shorter span within a panel. Here you again I am focusing on it, that is within a panel shall not be greater than 2. So that means code is saying that this method is applicable only for two-way continuous flat slab. That means two-way slab you can design, not one-way slab. So here again we are just seeing a portion of a flat slab having number of columns. So there will be various number of panels, and it is just to understand what is basically panel and what are the assumptions mentioned in direct design method. So third one is, now if we go again through second point, so this is the panel, that means there are various panel, and you can easily see that these panels are rectangular in shape. So this method is applicable when panel are rectangular in shape. Third point is the successive span length. Now what is span length? Center to center of support. So successive span length in each direction should not differ by more than 1/3 of the longer span. And the end span must be shorter but not greater than the anterior span if the slab which we are going to design in case of flat slab. So if it is fulfilling this third requirement, then you can go for the application of direct design method. Another fourth point is column may be offset to the maximum of 10% of the span in the direction of offset. So we have shown here, suppose if this column is not in the line as the other columns, that means their center line are not coinciding, and this column is having spacing, that means it is having some offset, then it is mentioned in the fourth assumption that this offset should be less than 10% of the span in the direction of offset. So in the direction of offset mean, now offset is in this direction and the span length in this direction is L2. So this offset should not be more than 10% of L2. So if all these applications assumptions may become the limitations for the direct design method, and the last assumption is the design live load shall not exceed 3 times the design dead load. So another thing which you have to keep in mind, this method we can apply where the load, whether it is live load or whether it is dead load, that will be in the form of uniformly distributed load, that is in the form of UDL. So these assumptions we have to keep in mind before applying the direct design method for the determination of bending moment and shear force as per IS 456. Now again, in the continuation of step number 2, first of all we will be finding the total design moment for a span. That means for different span you will be have to do the calculation. So total design moment, first of all we will be calculating for a particular span. For detail we have to refer clause number 31.4.2 of Indian Standard Code 456. Now you have to listen this lecture very carefully, otherwise you will not be able to design accurately. So total design moment mean here we are calculating first of all the absolute moment, that is total moment, which will be sum of factored positive and negative moment. So that means for a particular span we will be calculating total design moment, and later on we will be dividing it into positive and negative bending moment as per codal guideline. So again I am repeating, the total design moment, which consists of positive as well as negative bending moment for a span, will be determined for a strip bounded laterally by the center line of the panel on each side of center line of support. So you can easily understand in this diagram, that means this rectangular portion which I have highlighted, so you have to calculate total bending moment for this much portion. So we have seen this is the strip bounded laterally by center line of the panel on each side of center line of the support. Now this is the center line of support, and from each side we are taking into consideration this will be the panel, or this will be the strip for which design moment will be calculated. Now you can easily see here that this rectangular strip consists of, first of all, column strip plus half of middle strip on both sides. So this you have to keep in mind that first of all in this step we will be calculating total design moment for this portion, which will be later on divided, or you can say distributed to negative as well as positive bending moment. So absolute moment, which is total design moment, absolute moment is given by the formula m naught w ln over 8, where m naught is the total design moment, that is total design factored moment. W is design load on area L2 into Ln. So that means this will be the area bounded by two spans. Let us try to understand. Now what is Ln here? It is a clear span extending from face to face of column. Later on when we will do the design problem, you will be actually able to understand what is the meaning. So Ln is clear span extending from face to face of column. Now it is not center line to center line of column, it is face to face of column. Capitals, if there are capitals, brackets or walls, but not less than 0.65, that means 65% of L1. Now what is L1? L1 is the length of span in the direction of design moment, in which direction you are calculating the design moment. And L2 is length of span transverse in the transverse direction, that means in the perpendicular direction to L1. While calculating the length of span, now here you have to calculate L1 and Ln and L2. While calculating length of span, the following point need to be carefully considered. Very first point is circular supports. Now suppose there are circular supports. Circular supports shall be treated as square supports having same area. So that means if you have a circular support, you can calculate the area of circular support. Then assuming that this circular support area, same area we will be using for the construction of square support. So that means area of circular support will be equal to area of the square support, from which you will be able to calculate the size of the square. Second point which you have to keep into mind, when the transverse span of the panel on either side of the center line of support varies, then L2 shall be taken as the average of the transverse span. So to avoid any confusion in second point, you have to wait for the design problem, which later on we will be solving. Point number 3, when the span adjacent and parallel to an edge is being considered, the distance from the edge to the center line of panel shall be substituted for L2. So I am not focusing on these second and third point, because to avoid confusion we will be discussing these points in detail when we will be solving a numerical problem, that is a design problem. Now, as in the previous step, we have discussed that how to calculate the total design moment. Now we have to distribute this design moment into negative and positive moments. For this, you have to refer clause number 31.4.3. Now, as per this clause 31.4.2 and point 3, the design moment m0, which we have calculated for a panel, is to be distributed into negative and positive in a longitudinal direction. Now you have to first of all here understood clearly that there will be one direction will be longitudinal direction and other one will be transverse direction. So first of all, we are here discussing about the negative and positive movement out of that total movement. That means how much will be the negative movement and how much will be the positive movement in a longitudinal direction. So for that, we will be referring this clause number 31.4.3.2. So first of all, in an interior span, so span by span we will be distributing. In an interior span, negative design moment value will be taken as 65% of total design moment. So that means total design moment was m0 and we will be taking 65% of it as negative design moment if you are designing an interior span, and 35% of the design moment will be positive design moment. So we have divided total moment into negative moment as well as positive moment if there is the case of interior span. Now if there is end span, suppose you are designing the end span, then interior negative design moment, end span, interior negative design moment. In next slide you will be able to understand exactly. So this formula is given in IS 456, that is 0.75 minus 0.10 divided by 1 plus 1 oblique alpha c. So that means whatever be the value coming out from this bracket, so that will be the percentage of total design moment which will be considered as negative design moment at interior when there is end span. So that means if there is end span which is supported on columns, so you have to this moment which you have calculated, that will be for the interior support. Then positive design movement will be given by this formula. You have to put the value of alpha c. Let us discuss what is alpha c, no problem. Then exterior negative design movement. So for end span we have taken two type of negative design movement and one type of positive design movement. But in interior span, only negative design moment and positive design moment. So now what is alpha c? Alpha c is the ratio of flexural stiffness at the exterior column to the flexural stiffness of the slab at a joint taken in the direction movement are being determined, and it is given by summation of Kc, that means flexural stiffness of column, divided by summation of Ks, where K is symbol for flexural stiffness and S is for slab. So where Kc is sum of flexural stiffness of the column meeting at a joint, and this formula we can use EI upon L. Then Ks is flexural stiffness of the slab, and it is given by EIS upon LS. So let us again revise the same point. First of all, we will be calculating for a total design moment m0 for a panel. Then depending upon whether it is part of interior span or whether it is part of end span, accordingly we will be distributing bending moment into negative as well as positive. Now, to understand it more effectively, let us continue. So these points we have taken from the previous slide. Now we will be having a diagram where we can easily understand. So now you can easily see that there are number of columns are given. Suppose this AB span is exterior span and this BC span is interior span. So now you are able to understand what is the meaning of interior span or exterior span. So if you see the diagram, that means bending moment distribution diagram for exterior span, so you will be finding at the middle there is positive bending moment and at the support end there will be negative bending moment. And this support which I am highlighting, this support is the external support and this support is the internal support. So here we can apply all these guidelines. That means how you have to calculate. Now this is exterior span, or that means these guidelines are applicable. It is an end span. Interior negative design moment. Now let us discuss. This is interior part of the span, interior support you can say. So that means when you are calculating interior negative design moment, so this will be the moment at the face of the support, interior support. Now this is the positive moment which is given by this formula. So this is the actual meaning of the positive moment, and this negative moment at the exterior support. So this is exterior support which we have calculated by this formula that will be applicable here. Now here we have taken it in the form of m naught by q. In lecture number 10, we will be going through the second part of the direct design method. So that means in this first part we have discussed how to calculate bending moment which is to be applicable for the longitudinal direction. Now how to calculate the bending moment which will be considered towards the transverse direction, that we will be going through in lecture number 10. Thank you.